Hello viewers, welcome back. So we are going to continue a new hands-on which is a part of the certification designing and implementing a data science solution on Azure. I have covered these hands-on till work with the data in my previous video which you can view in my YouTube channel. So please have a look. We'll be continuing with work with the compute resource. Okay, I've opened this link in a new tab. Okay, now to work with the compute resource, we have to create an environment. Okay, so all the Python code runs in the context of an environment which determines the Python package available. The code can be run in an environment on your local workstation or some other compute target, such as cluster for increased scalability. Okay, so here in this case we'll be using a cluster based compute resource which is hosted in Azure cloud, and then we'll be running our experiment. For that we will create environments within a compute target and then start working with that. Before you start, you have to create a Azure Machine Learning workspace. That part is covered in my previous YouTube videos, so please go and have a look. I'm continuing to the next topic where we have to open the notebook and run the scripts provided within the Azure Jupyter notebook. Okay, Python Jupyter notebook within my Azure Machine Learning Studio. So here I have opened Azure Machine Learning Studio, and these notebooks that you see is part of the previous it's been covered in the previous video tutorial how to clone these notebooks from the GitHub. Okay, which is part of create a Azure Machine Learning workspace. Under that we have already covered that. Now I have opened work with the compute notebook, right? And also I have started my compute resource which is currently running. You need to start your compute resource which you have created to run your notebook within that compute resource. Okay, now when you run a script as an Azure Machine Learning experiment, you need to define the exact context of the experiment run. Okay, now the execution context is made up of the Python environment of the script, which must include Python packages in the script. So to run your machine learning, you need some Python packages, right? So all those Python packages need to be part of your script, and that script is nothing but the Python environment file. Basically, we'll see that how to create the Python environment file and then import it and use all the packages which are part of your environment file. Okay, the compute target on which the script will be run, that is also required. This could be a local workstation or the clustered environment that is hosted in Azure. So we'll be continuing with this one, cluster one, right? Now, first of all, we have to connect to our workspace, machine learning workspace, right? So we are importing these Azure ML Core package and then also the workspace package from Azure ML Core, and then try to print my machine learning workspace name here and the Azure Machine Learning version. Here you can see the Azure Machine Learning package version as well as my machine learning workspace name. Okay, now within that workspace we'll be creating our experiment, okay, to run the machine learning machine learning experiment or script. Now in this notebook we need to import the data set, right, which is part of data and folder location. So here if you go to the data folder location, you can see these two files. Okay, we'll be importing these two files into the data set right here, and we'll be importing those files as a diabetes data set, and the format of that file would be a tabular data set. Here you can see we are importing those as a tabular data. Okay. Now here we are registering our workspace data set, and then that will be a registered data set, a tabular registered data set within our workspace. Okay, so let's run it. So dataset already registered, and if you open the dataset link here in a new tab, let it load. In the meanwhile, I'll continue to the next one. So creating a training script that will go later. Let's see the dataset now. So here diabetes dataset has been created now. If we click on this, okay, so this is a tabular dataset. So if you click on explore, let it load, you can see the data being imported to dataset, right? These are patient with their IDs and their some health parameters, right? And their respective values mentioned here, based on which we will try to predict whether the patient is diabetic or non-diabetic. Okay, so let's come back to the notebook. So first, all the artifacts that we'll be creating under a diabetic training logistic folder. Okay, that's my experiment folder where I'll be keeping all the Python script and data set models, everything that we are going to run. Okay, so first of all, let's create that folder. So if I refresh this, here we can see a new folder got created, diabetes training logistic dataset, right? Nothing is there currently as of now. Here we are importing all the relevant packages to run our machine learning experiment. Okay, and that script will be written as this file name within this experiment folder, which is nothing but diabetes training logistic folder. Okay, with all the scripts, model, labels, test and train, or splitted data, all those will be written in that folder. Okay, so this script, this is nothing but our experiment script, which will be written as a file, okay, into this folder location. So let me execute this cell as well. And here we can see this file got created. So if I refresh this again, then we'll be able to see that file created here, diabetes training Python file, right? Now we are going to create an environment under which this experiment or diabetes training script will run. Okay, so here you see we are taking help of a YAML file. Okay, environment underscore env. This is indicating we can have def your prod related environment appended to the file name to indicate packages which we are trying to import here or put here in the environment folder will indicate for which environment we are preparing this file. Okay, so now let's run this. This will also be written into the same folder location. So if I refresh this, here we can see the environment file. If I click, you can see the file created, right, with all the packages which will be imported to or referred as a dependencies to run our experiment. Okay, and also the Python script file that is going to run within that environment. Okay, now can you use your custom Quantai specification file to create an environment? Okay, so now this Python experiment environment file that we created will be using that environment as a configuration. Okay, and then that under that configuration or the environment will be running our experiment later. So let's first You specify the configuration, environment configuration here, and now we can see this has been defined. Okay, next is creating a Docker compute configuration, okay, or resource or the container under which we'll be running our experiment. Okay, so that Docker configuration will make use of our environment file, the script that we are going to run under that Docker container, and the script where is this script will run, utilizing the training data, right, to train the model. Okay, then we are naming this as a experiment ms learn train or diabetes. So Microsoft learn train diabetes, that's my experiment name. We'll be making use of the workspace that under which we have created all these scripts and the notebooks, right? So same workspace will be used, and then let's run it. So it's going to take some time to execute. While it's running, we can see the experiment successfully used the environment. Okay, here you can see the experiment got created, okay, with this random name, and this is the experiment name. So now that experiment is being run here. Okay, and here we can print out all the matrices related to that experiment. Okay, so let this execution get completed, then we will run the matrices by script to print all the run related matrices. Okay, I'll pause the video for some time. Okay, so now we can see the experiment has been completed, and then within the notebook widget we can see the different values are related to our experiment which being run. So the status is completed, and it took almost 4 minutes 19 seconds to run the node within our cluster, and you see the model accuracy is 0.773 or around 77%. Okay, AUC values and regularization rate and ROC of image or the plot that has been saved as well within our experiment folder. Okay, and these are the logs which you can see by clicking in each of the log files. Okay, and these are all metadata being printed here. Okay, environment variable, if you see the base image for our cluster was a Ubuntu. Okay, now let's move on. So let's run this experiment cell to print the matrices values, and the same matrices or logs that were shown in the widget that you can also check using this. Okay, get matrix from run. Okay, so from run variable you can extract that values here. Okay, from run details you can extract all those matrices values. Okay, now how to register the environment. So if you see, this is the script to register your workspace. Okay, within your workspace. So I'll just having gone to the trouble of defining an environment with the packages you need, you can register it in the workspace. So first you define your environment file with all the packages that are required, and then you can register your environment within your workspace using this script, environment dot register. Okay. So this will register all the packages within your workspace. So this is our cluster and all the dependencies for or conda dependencies which are required to run your machine learning experiment are part of this dependencies, okay, of the conda environment. Now note that the environment is registered with the name you assigned when you first created it. In this case, diabetes experiment environment. With the environment registered, you can reuse for any script that has the same requirement. For example, let's create a folder and script to train a diabetes model using a different algorithm. Okay, so we'll be performing the same experiment, same kind of experiment, but we will be utilizing a different algorithm to run the machine learning experiment. Okay, so we are now going to create another folder location, and if I'll refresh, you can see new folder location here with this name, training tree, right? Diabetes training tree. Okay, all the artifacts related to that logistic you can see here, right? Now this is the new folder that we created, and let's save this script. Here we are using a different decision tree classifier algorithm. Okay, what we did earlier was a logistic regression, so I can show you that in the experiment. Predict logistic regression we used earlier, right? And this time we are using decision tree algorithm. Okay, so now this has been this script has been written to this folder location. If I refresh, you'll see that Python script here. Okay, now we are going to register the same environment. Again, we are going to reuse the same environment which is already registered. Okay, and we are going to use the same data set that we created in earlier diabetes data set, right, with the two files, these two files, diabetes and diabetes 2. So we have a data set already created here. Same data set we are going to use here. Okay, next, now here we are writing a script configuration where it will utilize this script, this experiment folder, then input arguments like data set, which data set to use for training, okay, which environment to use to import all the packages, and which Docker container to use. Okay, so this is the Docker configuration. Now that experiment is again named as MS Learn Training Diabetes dataset, and this time in this experiment we are referring our workspace and the experiment name that we have given, and then we'll be running this experiment again. Now this experiment will be different in terms of algorithm, but the rest of the things are same. Okay, so let's execute this. This is again going to take some time, so I'll pause the video and we'll continue once it's complete. Okay, this time you can see it took very less time to run the execution, and we can also see the execution time is accuracy is almost 89%. Okay, so this is all about running the same experiment using the same environment, okay, but with a different algorithm. And all the matrices and the logs are printed here. You can also print specifically all those matrices details, logs, everything. Okay, here in this section, how to see all the environments that we have created, okay, within our workspace, machine learning workspace. Okay, so environment is nothing but a package within our Azure ML core. From that we can print all the environment that are registered within our machine learning workspace using .list command and passing the workspace name. Okay, and out of that object we are printing all the environment that are part of this machine learning workspace. Here you see there are so many different environments created for to run different kinds of script, scikit-learn, PyTorch, and the operating system also indicated. Okay, now create a compute cluster. In many cases, your local computers may not suffice to process a complex or long-running experiment that need to process a large volume of data. So if you have a large volume of data and you expect it to run off for a very long time, you think it's going to take a very long time, then you want to take advantage of a dynamically create and use compute resource in the cloud. So it will be elastic in nature, or you can dynamically increase your compute resources, clusters, and decrease it. Okay, so that would be done dynamically. Now to do that, what you have to do, you can create a compute cluster in Azure Machine Learning Studio or by using Azure Machine Learning SDK. So we can go to Machine Learning Studio and create different clusters. Okay, or we can do it also through the Azure Machine Learning SDK. Here we'll be following the SDK. Now here it is asking you to put a compute cluster name, proper compute cluster name. So I'll just name it as a compute cluster. One. Okay, so this will be a new compute cluster created, and this compute cluster will be part of our machine learning workspace. This compute cluster will have a VM size of this, which is nothing but a standard dual core VM to run our machine learning experiments. Okay, so this will provision a VM with dual core for data science experiment. Okay, and then that compute configuration will be used to run our next experiment. Okay, so let's provision that. There is some issue, received bad response from the resource provider. Okay, what was the error? Received bad response from the resource provider. Okay, let me pause the video and check for the issue. Okay, there was some issue with the length of the compute cluster name, so I have changed the compute cluster name to compute cluster 1 like this, and let's again run this. So it is executing now and not throwing the error. Let's wait for some time to get the compute instance provisioned, and then I will show you how it looks like. Okay, so now this compute cluster has been provisioned, and we can go and check the compute cluster from home. You go to compute, and here you can see this compute cluster is being provisioned, right? If you click to see, you can see the number of virtual machine or related information, right? It could go up to maximum 2 nodes or minimum 0 nodes if it's not being used, right? And idle time to scale down is this one. You just divide it by 60, 20 minutes. After 20 minutes, if you are not using, it's going to scale down. Okay, so that's about the compute cluster that we provision now. Now we can use that compute cluster to run our experiment. Okay, again, so if you see this, these are the same script configuration, same Python script, training data, registered environment, but this time the compute cluster name we have changed. Okay, this cluster name is referring to the one that we created just now. Okay, so and if you check earlier configurations that were created, so here we were using the Docker runtime container that we wanted to use. This time we have created specifically a new cluster or container basically, which will be used this time. So let's run it again. This is going to execute our Python script, and here you can see the status in real time. It is preparing, resizing to run the experiment. Okay, and here you can see the random experiment name being generated, and in some time you'll see this being completed. You can see the current status is that the job has been submitted. Now I think job is being run. You can see the node run duration is started. That means it's trying to pull all the packages and then create the environment to execute our script. Now it is setting up the environment on the environment, right? Environment provisioning is complete. See, all these packages are being downloaded to set up the environment. So now the environment setup is done and the pip dependencies are being installed. Now the script is being run into this environment. Environment context has been created, and then this Python script is going to run into that environment. So it has progress. Okay, it's trying to run that. So this is our cluster image being pulled from Docker. While it is running, we can still see the cluster state and the count of nodes that has been created for our experiment. And we can see that currently the node count is 0. That means it's in idle state. You can run it again and again just to check whether it has been moved up, like up to 2 nodes, right? That's what we have set up, right? Maximum it could go to a node count of 2. And run. Wait for completion. Note that this will take a while before the status changes from steady to resizing. Now might be a good time to take a coffee break and to block the kernel until the run completes. Okay, run the cell below. Once this is complete, then we'll be able to run. Okay, and then see all the matrices from the run history. Now you can register the model that was trained by the experiment. So yeah, so we can also register this model under this model section. Okay, within our workspace we can check this model once we register this, and we can reuse multiple times on a newer patient data to predict patient is diabetic or non-diabetic. Okay, you can also refer these learning sections, okay, related to compute targets and environment. Okay, so I'll be pausing the video, and once this experiment completes, then we'll start again. Now we can see the status of this experiment is showing as running. and it took almost 14 minutes to go from provisioning to running state. Okay, so it's going to take some more time, so let's wait, and then once this is complete, we are going to run the cluster count information. Here you can see it's using now single cluster to run it, and once that this you can see one cluster is running and status is finalizing. That means it's going to complete soon. Okay, here we can see the accuracy is 89% now. Okay, earlier what was the accuracy? 89%, right? The same. And when we go down here, so this experiment is now complete, and let's again see the cluster count should be 0 after some time. And then we can click run, not wait for completion. So the node cluster node count is 1 still, and here we can see all the information related to the experiment. So this is our experiment run ID, our experiment name, our cluster name, status completed, computation details, data references, framework, data consumption, the data it took is training data, this is diabetes dataset location, diabetes dataset, this is being used for training the diabetes dataset, right? Training data, that's the environment variable name, all these information being shown here. Okay, that's a long list. This is the environment file, these are the dependencies, this is the image used to provision the cluster, and then log files and other things. Okay, keep an eye on kernel indicator at the top, right? When it turns black to white, the code has finished running. Okay, kernel is idle now, that means it has completed running, and then we can now print the logs and the plot image that has been stored within this experiment. Okay, now let's register our model within Workspace. This is our model name. We are going to check what this model name will register this. So training compute cluster, accuracy, and AUC. Now this model has been registered. If we click open the model, we can see the model name here. Diabetes model. Okay, so what is the purpose of registering the model? We can reuse this model on newer data to predict whether a patient is diabetic or non-diabetic. Okay, that's it for this tutorial. We will continue the next hands-on. Keep watching. Please like and subscribe my videos if it's helpful to you. Thank you. Bye bye.